Today we're going to look at arithmetic progressions, also referred to as APs. Now you've done this at GCSE, it is just basically your linear sequences. So if you have, for example, a number, then you add a number to that, you get a second term. If you add that same number, you get a third term, add that same number, you get a fourth term, and so on. So this is known as an arithmetic progression, AP for short. So A is classed as the first term, and what you go up by each time is D, which is referred to the difference between two terms. So the nth term, which is given the symbol UN, the nth term, usually what you would do is you'd say, oh, it's D times N plus a number, and you work out that number based on the first term. That's the GCSE approach. However, at A level, the way that we go with this is we say, well, hang on, the first term there was no D's, the second term there was one D, the third term there was two D's, the fourth term there was three D's. There's always one less quantity of D's each time. So the nth term will be A, the first term, plus N minus 1 lots of D. And that's the expression that we use at advanced level for the nth term. Now at advanced level, you are expected to also work out the sum of so many terms, referred to as Sn. So there is a formula for it, but first of all, I'm going to prove it to you, because for many exam papers at A level, you need to know the proof. So what I have is I have the first term, the second term, the third term, the fourth term. It carries on. I could carry on the fifth, the sixth, the seventh, all the way through to the last term. Now I refer to the last term as L, L being that general term that I've already explained. Now I use L because it makes it easier to prove the formula. The term before the last term will be the last term minus D. The term before that term will be another minus D, so L minus 2D, and so on. Now the reason why I write it like that is because when you add numbers together, it doesn't matter if I add that way or if I add that way. So what I'm going to do is I'm going to write down that the sum could have been L plus L minus D plus L minus 2D plus, and it carries on all the way through to what I have at this other end. I'll just write a couple there, A plus 2D, A plus D, and A. So I have got two expressions for working out the sum of n terms. Well, if I add these two expressions together, I end up with twice the sum. Now the reason why I do that is because here I've got A plus L, I've got A plus L. Here I've got A plus D plus L take D. They cancel one another out, so I'm left with A plus L. A plus 2D add L take 2D. I think it's becoming a bit obvious what's happening each term here, and it just carries on doing that. Now basically what I've got is the set of numbers is there's n numbers there. So we've got n lots of A plus L. So therefore the sum of n terms, because that's twice the sum, is going to be half of that. However, the last term was the expression A plus N minus 1 D. It was just easier to write it as L for the process that I've described up there. However, if I put that back in, that it was actually A plus N minus 1 lots of D, A plus A is 2A, plus N minus 1 lots of D. And that is a formula that's used at A level for the sum of n terms. So we now have an expression for the nth term, which is that part there, A plus N minus 1 lots of D. We now also have a formula for the sum of n terms, which is a bit trickier to learn, but that's it. So here is a typical kind of question that you'd have at A level regarding your sequences. You're not told the sequence to carry on, as I've just shown with algebra of first term, second term, third term, etc. You're told some information which allows you to set up equations to be solved. So here we've been told that the 10th term, so U10 for 10th term, is 45. Now the formula for that is A plus n minus 1, so 9, D equals 45. There's a formula created. Then we're told that the sum of the first 10 terms, so we've been told that Sn is equal to 270. Well, the sum of 10 terms means we've got a half of 10 bracket 2a plus n minus 1 d is equal to 270. Now that is 5, and what I always do is I always just take that across to the other side. So we've got 270 divided by 5, which comes out to be 54. And basically, you have two equations to solve. So if I was to subtract those two equations, the 9a and the 9d and the 9d cancel. The 2a take the a, it gives me 1a. And the 54 take the 45 gives me 9. So a works out to be 9. Well, if I put 9 back into there, then I will get that 9d is equal to 36. And if 9d is equal to 36, that means that d works out to be 4. It's basically solving simultaneous equations. Then in part C, we're using the formula again, the sum of 15 terms. So we get half of n, so 15, times 2a, so that's 18, plus n minus 1, so that's 14, 15 take 1, 14, times d, which is 4. And you just put that into the calculator. So we got 18 plus 14 times 4, times that by 15, and divide the answer by 2. And that comes out as 555. Rather than with the second example. So in this particular example, the first term is 3. So we've been told what a is this time. However, we've not been told d, and we've not been given a particular term. We've said that the nth term. So the nth term is equal to 93. So a plus n minus 1 lots of d is equal to 93. So it looks a bit more challenging. The sum of the first n terms is equal to 768. So we've got a half n, 2a, so 6, plus n minus 1 d is equal to 768. So that's replacing the a with what we know it to be. However, we have some challenging parts there. Though I on purpose didn't remove that because I can see it's there as well. If I take the 3 across the other side, I can see that that quantity is equal to 90. So I can replace that with a 90. So I get half n, 6 plus 90 is equal to 768. So there I've got 96. So I half the 96 and I divide the 768 by that quantity, because basically here I've got 48n. So to work out n, I would divide that 768 by 48. That comes out to be 16. So we were looking at the 16th term. Now that I know that that's 16, I can go back to here and I can say that 15d, because 16 take 1, is equal to 90. So therefore, to work out d, I would divide 90 by 15 and come out with 6. Whenever they use the sum, that is the more challenging simultaneous equation setup. So here you've got a question which is more challenging, that we've got the sum of 30 terms being 105, and we've got the sum of 50 terms being 675. In each occasion you replace the sum expression with the formula. So we get half of n, so half of 30, 2a plus n minus 1 d is equal to 105. And as always, that I'll write down, but half of 30 is 15, and you just put 15 into 105. So 105 shared by 15 comes out with 7. That's first equation. So same for 50, sum of 50, we've got half of 50. We've got 2a plus n minus 1, so 49d equals 675. So I'll write down that expression. But half of 50 is 25, and we've got 675 divided by the 25 is 27. Now to solve these two simultaneously, it's actually not that bad because they both say 2a there. If I subtract the two equations, the 2a's go, and when I subtract those, I get 20d. And when I subtract those, I get 20. So d works out to be a nice value of 1. So if d is equal to 1, I can put that into either of these setups. I'll put it into the first because the numbers are smaller. So 2a add 29 is equal to 7. So 2a is equal to minus 22. So a works out to be minus 11. The next part, I need some more paper for, we've got to find the sum of the first 27 terms. So the sum of 27 terms, we quote the formula, half of n times twice a plus n minus 1, so 26, times d. And we just throw that into the calculator. So we got minus 22 plus 26 basically, which we don't need the calculator for, times 27 divided by 2 equals 54. Done. Finish off. This is a question that was set in the 1990s, which uses everything that I've just shown you. It actually starts off the same sort of format as an earlier example where they tell you that a is equal to 3. We're told that the 7th term is, so equals, twice the 3rd term. The 7th term is twice the 3rd term. Well, the 7th term would be classed as a plus n minus 1 d, and that's equal to twice the 3rd term, which would be 3 plus n minus 1, so 2d. So we've created an equation there. So 3 plus 6d is the same as 6 plus 4d, which means that 2d is the same as 3, which means that d is fractionally 1.5. D found. Then to work out the sum of 20 terms, we once again put this into the formula. Half of n twice a, so 6, plus n minus 1, 19, times by d, which is 1.5. And we throw that into the calculator. So 6 plus the 19 lots of 1.5 equals, and then just times that by 10 arguably, because half of 20 is 10, and that comes out as 345. That was easier than the simultaneous equation type. This is another arithmetic progression question from an exam paper we're told that the 10th term is 34, and the sum of the first 40 terms is 2,620. So the 10th term means A plus 9D is 34. The sum of 40, so half of 40, I'll write that as 20. 2A plus n minus 1, so we've got 39 times D is equal to 2,620. As I've said in previous examples, I'll just leave that there, but I would take the 2,620 and divide it by that 20 straight away. That gives me 131. So these two don't match up this time. However, I can just quickly double this one. 2A plus 18D equals 68. And then it allows me to subtract these two. So the 2A take the 2A disappears. The 39 take the 18 gives me that 21D is equal to, and the 131 take the 68 gives me 63. So D works out to be 3. Put that into either expression. This is the easiest numbers. So we've got A plus 27 is equal to 34. Take the 27 across to the other side and take the 27 off. You get A is equal to 7. Question done.